All right, 8th graders, we are in the last section of Chapter 3. This section is going to cover lines in the coordinate plane. Now, most of what you actually are doing today, if not all of it, is review. So if there is something that you're thinking, okay, I know this, there's no problem with this, then you can skip over the section that I'm going over. But the reason why we're going over it is because we're adding theorems and postulates that's going to use some of these things we're going to talk about. Now, you don't need to write this down, but it says that the equation of a line can be written in many different forms. The point-slope and slope-intercept forms of a line are equivalent. Because the slope of a vertical line is undefined, these forms cannot be used to write the equation of a vertical line. These only can be used to write an equation that's non-vertical. Here are the forms of the equations of a line. So the first one is point-slope form. Point-slope form is y minus y sub 1 equals m times x minus x sub 1. M is the slope, and x sub 1, y sub 1 is the given point on the line. As you can see, the example over here is plugging those in. Slope-intercept form is y equals mx plus b. M's the slope, b's the y-intercept. The equation of a vertical line is x equals a, where a is the x-intercept, and the horizontal line is y equals b, where b is the y-intercept. All right, in example number 1, we're going to write an equation of a line. So each of these we're going to write an equation from. So example A, the line with slope 3 through 2, 1 in point-slope form. So the first thing we need to do is write down point-slope form. Point-slope form is y minus y sub 1 equals m times the difference of x and x sub 1. Well, we know the slope is 3, so we're going to plug 3 in for m. And we know 2, 1 is our point. So that represents x sub 1 and y sub 1. So if we plug that in, that would be y minus 1 equals 3 times x minus 2. And there's my answer. Example B is we want to write an equation of the line that goes through points 0, 4 and negative 1, 2 in slope-intercept form. So y equals mx plus b. The first thing we have to do is find the slope. Well, the slope is subtracting our y, so I'm going to do 2 minus 4, and subtracting our x's, negative 1 minus 0. That gives me negative 2 divided by negative 1, which gives me a slope of 2. So we know our slope is going to be 2. Now, I'm going to use one of these points, and I'm going to plug in x and y to find b. Now, there are obviously different ways to do this. So 4 equals, my slope is 2, times 0 plus b. Our b is 4. So I take our b, which is our y-intercept of 4, which you can also get just by looking at the point 0, 4. My slope is m, which is 2. My equation would be y equals 2x plus 4. Y equals 2x plus 4. Example C, we want to write an equation that through the line with x-intercept of 2, y-intercept of 3, in point-slope form. So, x-intercept of 2. That means I have a point of 2, 0. A y-intercept of 3 means I have the point 0, 3. The first thing I have to do is find the slope. That would give me 3 minus 0, which is 3 as the rise. And 0 minus 2, which is negative 2, is my run. So my slope is negative 3 halves. So I can use either point. So I could use y minus, remember we're doing y sub 1, equals m times x minus x sub 1. If I use 2, 0 and plug that in, that would give me y minus 0 equals my slope, which is negative 3 halves, times x minus 2. If I simplified that, that would just give me y equals negative 3 halves times x minus 2. If you used 0, 3, you would get y minus 3 equals negative 3 halves times x minus 0, which would give you y equals negative 3 halves x plus 3. Now notice that you could leave it like this as well. If you actually simplified either one of these, you would get the same answer. So either one would be an acceptable answer. Now here, we've graphed before, so I would assume you can do this, but I'm going to quickly spend, you can even time me, about 30 seconds explaining this. In A, if you are graphing this line, y equals 3 halves x plus 3, we know our y-intercept is 3, so we put a dot on 3. My slope is positive 3 over 2, so I go up 3 over 2, put another dot, and I draw a line between it, and there's my line. The next one, B, y plus 3 equals negative 2 times x minus 1. We know that it would go through the point 1, 3. So, 1, negative 3. We know my slope is negative 2, so I go down 2 over 1. I'm going to actually spend a few more seconds going over this one at the bottom. Remember once again, if this is in point slope form, x minus x sub 1. That means x sub 1 is 1, not negative 1, just 1. Y sub 1 would be negative 3, because when you plug it in, it becomes positive. So we know my point is 1, negative 3, and my rise of negative 2 means it's negative 2 over 1. So negative 2 over 1 means I go down 2, right 1. In example C, x equals 3. That means that I have an x-intercept of 3, 0. That means I have a vertical line that goes through the x-axis at 3, 0. Now to also review what we did, or what you guys have done in the past, is when you have systems of two linear equations and two variables, which represent two lines. These lines can be parallel, intersecting, or the same line, which is called coinciding. Lines that coincide are the same line, but the equations may be written in different forms. So parallel lines, if you look at them, they have to be solved for y. They have the same slope, different y-intercepts. Intersecting lines have different slopes. Notice that intercepts don't matter here. If they're different slopes, they're intersecting lines. Coinciding lines means you have the same slope and same y-intercept. So example 3a. Example 3a, we have two equations. Y equals 2x plus 3, y equals 2x minus 1. They are both solved for y. We know their slopes are the same. So the lines are parallel. But notice that the y-intercepts are also different. Therefore, same slope, different y-intercepts, the lines are parallel. In example B, the first equation is solved for y, but we need to solve the second equation for y. So we would get negative 2y equals negative 6x plus 10. I divide everything by negative 2. And I get the same equation. Because I get the same equation, that means the lines coincide. They're the same line. So now in the next example, we can solve these. Let's solve them for y. The first one is going to give us 2y equals negative 3x plus 7. Divide by 2. That gives me negative 3 halves x plus 7 halves. The other equation, if I just divide everything by 3, gives me 4/3 x plus 7/3. Instantly, we have different slopes. Different slopes means that the lines just intersect. In example 4, we're doing a problem-solving application. Audrey is trying to decide between two health club plans. After how many months would both plans' total cost be the same? So we have an enrollment fee and a monthly fee of plan A or B. I'm hoping, which I know you've done this in the past with systems, plan A would have a fee of $35 per month plus an enrollment fee of $140. And that's going to give me equals y. And then our second equation would be the total cost, which is y equals 55x plus 60. Since they're both equal to y, we can set them equal to each other. Since we want to know when they're going to be the same, And using substitution, and I apologize, that was the announcements. So then we have 55x plus 60. Solve this equation, I subtract the 60. That gives me 80 equals, subtract 35, 20x. That gives me x equals 4. So then what does that mean? We want to know, if you graph these, where would the lines cross? Well, if x is 4, that means after 4 months, they would be the same, but how much would they be? Well, take the 4, plug it back into either side. You could take 35 times 4 plus 140, or 55 times 4 plus 60. And after 4 months, they each cost $280. Now in this chapter, or this section, the vocabulary that we learned were just two: point slope form and slope intercept form. However, I am sure that you already know those, so you don't need to write them in your vocab list if you do not want to.